Okay, we're back. Alright, so, hopefully everybody can see me okay. So, hang on a sec. See if you guys can see me or not. Hopefully, question mark. Alright, cool. Alright, if you guys can see me, that's okay. For some reason, I can't see me, but that's alright. I usually follow along here, so I guess I'll kind of roll with that, I suppose. Question mark. Alright. Hey, I think I got it. Alright, cool. Alright. Hey, how's it going, everybody, today? I've fixed. Good morning. Good morning to you, Hisa. Well, I do want to say that I said it in the first class, but I'll say it here too. I've effectively I've made a lot of changes to the stream. I think I worked out all the wrinkles there. Now, as you can see here, the settings are now at 1080p. So now I'm working at 1080p, so much cleaner and nicer stream here. So hopefully it'll continue to be that way. So if there are hiccups, I didn't get any hiccups in the first part of the stream, so hopefully no hiccups in this stream either. Okay, is what I'm hoping for. So hopefully we should be okay for today's class. So I did a lot of different things on my computer over the weekend just to see what would work and what didn't. You invested in Tesla. Oh boy, rough day for you today. Um, it's a rough day. But if you're long in Tesla, then yeah, and if you're long in Tesla for like a year or two, yeah, you'll probably get a good return in that. So today is a rough day, but I think yeah. So if you're long in Tesla, you should be fine. It's down $60 today, but again, in the long-term perspective, it's probably going to surpass that once really things start to get back to normal from coronavirus. Yeah. Have I heard of NIO? No, is that like one of those electric truck companies, or is that another electric car company? Sounds like an overseas company. Yeah. All right. If they're trying to rival that of Tesla. See, with Tesla though, the thing is with Tesla, it's not just an electric car company. With Tesla, it's more than just that. You know, it's Hyperloop, it's SpaceX, it's a lot of different ventures that Elon Musk wants to go into. So yeah, if it rivals that of Tesla, that's fine. They're things that electric cars still need to work on much better. They're not quite there yet. If there's only one thing that holds back electric cars, really, in all honesty, there's only one thing that truly holds back electric cars. Actually, two things. Number one, infrastructure of more electric charging ports, and number two, how fast you can charge. You know, can you get it to a point where you can fast charge like a phone? You know, where you're not sitting for half an hour. Like if you were pumping gas and you do it like for 5 minutes and then that's it. So yeah, we're not there yet. So if the technology gets better and you move away from lithium ion, then you'll be in better shape. Lithium ion's not great, so all right. In any case, though, we got stuff to do here today, so let's do it. All right. Okay, let's go ahead and get started here for today. Welcome back. Welcome back to Tuesday. Hopefully, everybody had a very wonderful, 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 wonderful Labor Day weekend. All right, so we're here for the first of 2 meetings this week, so let's go ahead and get started. So today what we're going to be doing is we're going to be talking about kind of the rest of section 1.5, go through 1.6, which is long division, and we're also going to do pretty much the first half or first 3/4 of section 1.7. So we're going to get a lot of stuff done here today, as a lot of the things that we'll talk about here today isn't going to require too much effort to kind of show if we want to be perfectly honest here. So the first thing we'll talk about here is divisibility. So divisibility is if you take one number, divide it by another number, and we get a remainder of 0. So if we say, is 6 divisible by 3? Well then, yes, because 6 divided by 3 is 2, remainder 0. Okay, so something to that effect is basically what we get here. So again, it's not too hard to figure out that, that's what divisibility means. Fairly straightforward. Again, this is on page 40 of your handout there. So there are numbers that you can do little tricks with to figure out if you can divide a number by a certain other number. So meaning to say, to test for divisibility, so any number that you can divide by 2 is if the last number in that sequence ends in a 0, 2, 4, 6, or 8, so essentially an even number. Alright, so pretty simple. If it's 4, if the last 2 digits make a number that's divisible by 4. 5, if it ends in a 0 or 5, so very easy. So if the number ends in 0, 5. 6, if it's divisible by both 2 and 3. 7, unfortunately, doesn't have a simple test. 8, if the last 3 digits make a number that's divisible by 8. 9, if the sum of the digits is divisible by 9. And 10, if it ends in 0. Now, notice the one that I skipped here is 3. I did that on purpose here, and that for 3 here is if the sum of the digits here is divisible by 3. So what that means is, let's go over that really quick, is if we had the number 123, then the sum of those numbers here is 1 plus 2 plus 3. So we actually add those 3 digits together, 1, 2, and 3, and that's equal to 6. And 6 is indeed divisible by 3. Again, 6 divided by 3, 2, with the remainder 0. Right? So just like so. Alright? So that's a way we can check to see whether or not that indeed is going to be divisible by 3 or not. Okay? So let's go ahead and look at a few examples here to see what's divisible by 3 or not. So simple yes or no answers here in the chat. All right, so very easy. So let's look at this first one here. 258. Is 258 divisible by 2? So is 258 divisible by 2? Again, just type yes or no in the chat there. Yeah. I'd be like, yeah, right? The last number here is even, so it's solid, good to go. You can divide by 2. Easy peasy lemon squeezy. Okay, agreed. How about 307? Yeah, that's right. The answer is no. Alright, it ends in 7, which is not an even number. Alright, cool beans. Alright. Alright, let's look at another number here. Let's look at this one here. We want to find out if this number here is divisible by 3. So 374,214. Is that divisible by 3? Remember, as I just said here, take all these numbers and add them together, and is that sum going to be divisible by 3? So again, yes or no in the chat there. Is that divisible by 3? Not sure? That's okay if you're not sure. It's not a problem. Sure, that's it. No, I understand. If you're not sure, that's fine. What do you think? Is 374,214 divisible by 3? Again, take each digit here and add them together and see if that sum is divisible by 3. So let's take a look here. Alright, so take a look here carefully. So I'm going to do this out here. So 374,214. You want to do 3 plus 7 plus 4 plus 2 plus 1 plus 4. And if you add those together, you're going to get 21. And if you take 21 divided by 3, well, that's 7 remainder 0. So the answer is, in this case, yes. Yes, this, again, even if it's a big number like this, 374,214, that is still going to be divisible by 3, just doing this small check here. Are there any questions about that? I hope that makes that clear about how I did that. So I want to be sure that that part there is a little more clear about what kind of the expectation is. Okay. Divisibility by 5 and 10 is pretty easy. I know most people actually know this. Divisible by 5 if it ends in 5 or 0. So if it ends in 0, then that's divisible by 5. This is divisible by 5 again and ends in 5. 5s and 0s are very straightforward. They don't require too much effort. And divisible by 10, if it ends in 0, it's divisible by 10 automatically. So just look at the last number there. If that last number is not 0, well, you can't divide by 10 evenly. It's not going to happen. Okay, so A, C, and D, they definitely do, but B does not. So as you can tell here, not so hard. It's just a very quick check about what that last number is, and that's all you need to do. All right, so that is pretty much the latter half here. I'm just going to kind of skim this over because we're going to mostly apply this in some form or capacity. So we'll see the applications of doing divisibility. All right, so you know, I kind of want to focus on that more than I kind of want to focus on necessarily, you know, all the tricks of the trade. All right, so because you get to use this over and over again anyway. So really, it's just kind of something to look out for. And since you'll get more practice with it with different types of problems, you'll see this used over and over again anyway. All right, so we're going to kind of skim that there. Now, the next section here, we're going to not do 9-3. We're going to do straight to 1-6. All right, so let's go to 1-6 here. 1-6 is long division. So we did a little bit of shorter division, but now we're doing long division here. Now, before we start this section here, and so to make this a bit easier, okay, for you, again, if you have one, okay, please make sure to take out a calculator. All right, so if you have a calculator there, go ahead and take that out. So make sure you have a little calculator out, because we're going to use the calculator as a little bit of a helping tool here in order for you to show me the work behind how to do long division. Because we're going to take a somewhat kind of a shortcut method here to do long division, but at the end of the day, I still want you to show me the work behind it. So that's how we're going to kind of approach these problems here. So I'm going to go ahead and show off the first example, and then you'll see exactly what we're working with here. All right. So let's take 3066, and we're going to divide that by 42. Alright, so let's go ahead and write that in. So 3066, and we're going to divide that by 42. Okay, so on your calculator here, what I'd like you to do is do 3066 divided by 42. And can anybody tell me what that's going to be? Okay. Good. That's correct. So the answer indeed, yeah, that's right. Nice, nice. Alright, so on the calculator there, I agree with all of you. The answer is indeed 73. Absolutely spot on. Alright? Now what you're going to need to show me, though, is of course the work behind 73. So you're going to need to show me just like we did last time. You'd be like, okay, we did this last time where, you know, we just kind of went through the steps here, just doing it step by step to show what we would get here in the end. So 73 is a straight up answer. I know that's 73 remainder 0, but I want you to show me the work anyway. So in this case here, let's go through the work part of the process so you're demonstrating to me that you know what's going on here with long division. So here we're going to take this 7 and we're going to multiply it by 42. So what's 7 times 42? Again, you can plug that in if you like. So 7 times 42. Alright, 294. Alright, and again, we're going to subtract. So we got 306 minus 294. Alright, 12. That's right. So you're going to bring down the 6 here. Okay. So we got, okay, spot on. And then take that 3, you multiply it by 42. And if you do that, you will actually get straight up the 126 that you're looking for. And so that will net you your remainder there at the end, which is 0. It should be 0, right? Because it's straight up 73. Alright. So you can see how we kind of, like, to show off the work here, we kind of did the same thing we did last time. We're just kind of working with a little bit of a shorter method here, because certain numbers can take a long time to kind of do with the head calculations there. They do take quite a while. So you know, 42 is not the easiest number to use in the world. Okay, it's not easy to see that 7 is going to be 306's counter nemesis or whatever. So it's not so easy to see. So hence why I'm taking kind of like the shorter route in this case, as opposed to doing kind of the super long route. So okay, let's go ahead and do another one here. Not that one again. Yeah. Okay. Go ahead and erase this out. And so we have 8784 divided by 61. That's this one down here, letter C. Alright, so let's go through the steps on how to show the work for this. Okay. Alright, so what do we get here in this case? 8784 divided by 61. Okay. Perfect. Alright, so 144. Spot on, everybody. Okay, now again, you need to show me the work behind this. So let's go ahead and met out the work. So here we have 1. We're going to get 61. 1 times 61 is 61. Okay. We'll subtract. Here we get 26. Bring down the 8. That's going to be 4. 4 times 61, if you do that out, is going to be 244. Here we subtract, we get 24. And then bring this down here for another 244. 4 times 61 is 244. Okay, so this justifies our answer here of 144 as our final result. Alright. Alright, so there are any questions about that? It's not very hard, obviously, but then we'll take it up a notch here in the next example. But before we do, any questions? Okay, well, let's move on to the next question then. And that is, these numbers here that we did in the previous two examples are very simple and straightforward. The reason why is because we get a remainder here of 0. And albeit a remainder here of 0 is simple to work with, not every number divides nice and clean and evenly. So let's take a look at an example where we may get a remainder here as part of our result. Alrighty, so we're going to look at the next problem here. Alright, so the next problem we're going to look at here is going to be, let's see which one. Let's do this one. Alright, so we're going to do this one here. So I have, put that in there. 89 here on the outside. On the inside we got 6649. Okay, so this is going to be our problem here. We have 6649 divided by 89. Alright, and again, most numbers are not going to come out clean. They can, it's just never always a guarantee. So again, that's why we include remainders there as part of the process. Okay, so if you put this on the calculator here and you say, alright, 6649 divided by 89, alright, you're going to get a number, and then you'll have a decimal after that. You'll get, like, you know, some number dot blah 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 blah. Now, thing is that we don't care about what's to the right of that decimal. We only care about the whole number that we get there. Alright, so let's take a look at that. So we do 6649 divided by 89. What's that whole number that we get when we divide that out? 74. Okay, nice. Okay. Alright, let's go over 74 here. Alright, so 74, we're going to take the 7 times the 89. Alright. Alright, so 7 times 89. Now, what do we get there if we take 7 times 89? What's that going to be? Okay, 623. Alright, very good. Okay, and when we subtract here, 664 minus 623. 41. Bring down that 9. Perfect. All right, then we're going to take that 4, multiply it by 89, and what do we get there? All right, 356. All right, very good. Good, good. So let's take a look here. Now the rest of this here is going to be our remainders. So we ignored that decimal part, and we don't care about it putting in decimals. We want to put it as a remainder. So if we subtract these two from each other, what do we get left over? 63. Good. So our final answer here is going to be, all of you, very nice. All right, good stuff. That's 74 remainder 63. All right. So that's going to be our final answer for this problem. So as you see here, we went through the process here. We did find a remainder. Remember, not every number is going to necessarily go even. And there we go. We got our final result. All right, good stuff. Are there any questions about that? All right, no. All right. Now, let's look at the next example here. Actually, that's not a bad idea. Should I do that? Yeah, you know. All right, let's do the next one here. I'm going to pick the next one here. There we go. That's my next buddy here. Ba-bam. All right. So, all right. So I'm going to do 23,462. And we'll divide that by 78. So what I'm going to do here, I'll give you a couple of minutes, okay? And I want you to work this out, all right? And see what we get here for our final result, okay? So let's take a couple minutes here. You guys write it on a sheet of paper. You know, again, you could use the same technique we did in the last example. And again, once you have your answer, go ahead and type that out in the chat, all right? Okay, so you get, so let's see a couple of them. 300 remainder 62. All right. See if anybody else wants to type something in. All right. Give another 30 seconds here. It's okay. That's okay. I'm going to go through the problem there, Samantha. I'm not just going to state the answer. I'll go through the problem. I think I know where you're hanging up on there, Samantha, so that's why I'm going to go through the problem here carefully. All right. I think that should be enough time there. Okay. So let's go through this problem here. And let's see if we do indeed get 300 remainder 62, as a lot of people have put down here. Do I want you to get the first part? Yes. To get the first part of 300, yes. That is what I would like you to do there, Carissa. So if you divide that out, the whole number component here on the calculator here is going to be 300. Okay. Then you need to just show me the work starting from the 300 to get your remainder. So we're going to talk about two. So there's basically two parts of this problem. You say, okay, I get the whole number here from doing the calculator stuff, but now you got to show me what the remainder is after the fact. So that's basically what we're after here in this case. So just kind of showcasing that. Now, if we do 3 times 78, if you do that on the calculator there, that indeed is going to be 234. That is exactly 234. And if you just subtract, well, then you get 0. But just like we did in the last problem here, we bring down the 6. And 78 goes into 6 0 times. So you have a 0 here. So 0 times 78 is still 0. Even if there's a 0 there in the middle, you still have to represent that 0 there, because we need to go all the way to the end of this number. We still make the same subtraction. So even if it's with 0, which effectively really does nothing, but at the end of the day you still need to represent it. Then I bring down this 2. I figure out how many times 78 goes into 62. The answer is also 0. So then I would have 0 down here, because that's 0 times 78. So our remainder here is 62. And so that's going to be our final answer for this problem here. Is exactly right. 300 remainder 62. Okay. Are there any questions about that? I want to be sure that that's now clear for you, Samantha and Carissa. Hopefully that makes sense about how to do that. No, you should do nothing with the decimal. We're not going to be dealing with decimals until we get there. We're only going to restate stuff with remainders here in this chapter. That's why we need to find the remainder, because that effectively takes care of the decimal part. So that's why we're only looking at the whole number there. Any more questions, Carissa, Samantha? Any more questions? Make sure we're on the same page there. Hello. Oh, whoops. Well, yes, you were yes. 23, 462 divided by 78. Yeah, but you just need to split that up into 2. Oh, times. Ooh, whoops. Yeah, that would be that would be it. That would be a problem. It's no wonder why you kind of got like a ridiculously large answer. You're like, what happened here? Oh no. Okay. Cool. Yo, my slime. I wonder why slime. Anyway, okay. All right, let's go ahead and talk about one more shortcut we can take, and this one's pretty well known with tens, hundreds or thousands or anything, any power of 10 really. You can effectively eliminate zeros by dividing by 10, so you can basically make the problem significantly faster by just kind of getting rid of zeros here. So I'll just show it off though, of course. So here we go. Okay, so if I did this question here of 505,000 so 505,000 divided by 1,000. So effectively for this, we go ahead and eliminate the zeros here. So this 0 is basically cancels out with this 0 cancels out with this 0, and this 0 cancels out with this 0. Okay. And so if we just cancel out the zeros there, we're just with 505 over 1 or 505. Okay, so that would be our answer for this problem because we can cancel out the zeros there as appropriate. Now I do want to make a note regarding this because I want to be sure that people don't get confused here. So let me put a note with this one. Note, this doesn't work all the time. Okay. Now I know it doesn't say this in the book, but because there's a subtlety to this. And why doesn't it work all the time? Well, it works if I have, say, 3 zeros, or if I have zeros at the end. If I have zeros at the end like this, then I can cancel out with these 3 zeros. But if these were like 1, 2, and 3, like, 505,123, then I can't cancel out any of these zeros. Okay, it doesn't work like that. If this, like, here's another way if I looked at it. I can do it halfway if I can. So if I said 150 and I divide that by 1,000, I can only cancel out one of those zeros. The other two I'm not allowed to, because this is not a 0 and this is not a 0 either. Even if this was a 0 here, I can't cancel out this 0. I have to cancel out the first 0 before I do. So again, this doesn't necessarily work all the time where I could just get rid of everything. I have to have if I want to get rid of all the zeros on what I'm dividing by, well, I have to have the same number of zeros here on the top at the end of the number. So if I don't, then it's not going to happen. I could stop halfway through the process. That's possible, right? Again, it's like just like 7,500 over 10 divided by 10, for example. Well, you could just cancel out 1 0, and that's it. Okay, you can't do any more than that because you only had 1 0 to cancel out with, and that's already gone. So that's where you get 750 for that. Just as a little side example there, just to make things clear about how it works with zeros, so it's not confusing. Like I said, it's not hard. It's just, again, that little subtlety there with how things work. Any questions about that? No? Okay. All right. Good stuff. Okay. So let's go ahead and show off another shortcut here of using that rule. So there is a nice little shortcut here, and that is like contained within this problem. This is actually a really good problem just to kind of highlight one very important thing in math. So I'm going to go ahead and write this in, and you'll see what I'm talking about here in this instance. So here we got 3,400 on the outside. All right, so we have 190,400 divided by 3,400. Now here's the thing about this, is that sometimes in math, you can make problems a bit easier, okay? A question on the homework assignments. Do we have to show work? No, you don't have to show the work on the homework assignments. You'll just have to show the work on the tests. So, yeah, just to let you know, you don't have to show me on the homework assignments, just the tests. So, because I do want to see your progress there, so for the test stuff. I'll describe more about how to do that because I have to set up the assignment Dropbox for that, for the test work. Because you guys will scan it and then give it to me or something like that. So hopefully that answers the question there. That's what I'm hoping for anyway. All right. So what I'm trying to say here is I want to make the problem shorter. If I can make the problem easier on myself, then why not do it, right? Because with larger numbers, it can be a pain. With smaller numbers, it's definitely not. So how do I make this smaller? Well, I use the same trick we did in the last example. We can cancel out this 0 with this first 0, and we can cancel out this second 0 with this second 0. Okay, just like so. So we can now transform this problem here into 34 on the outside and 1,904 here on the inside. And you can see here that this is significantly easier than the previous problem with hundreds of thousands, now just boiled down to thousands. It doesn't work for every problem, no, but if you can shorten it down, you'll see a lot of concepts as math is like, if we can shorten it down, by still following the same math properties, hey, take the chance and go ahead and do it. So that way it's a less of a strain on your brain. Okay, so if we're going to do it the laziest way possible, we'll try and make it easier before we even start the problem. That'll make it a lot better for us in the long run. If you do this out, what is this answer to this problem here? Let me do this out. Oh yeah, okay, so we get 56 for that. All right, so this is 170. Yeah, is that 100? Oh yeah, that's right. Okay. For some reason I thought that was off, but no. And yeah, that's 204. Okay, so there we go. So the answer here is 56 straight up. But you can see here how we pared it down into something significantly easier, and then it wasn't so hard after that. And then it was like, okay, this is pretty chill. So all right. Questions, comments, concerns, complaints? No. Okey-dokes. So far, so bueno. Doing good. All right. Okay. All right, we're going to move here to the very next section. The next section here is talking about rounding whole numbers. Okay. So we're going to talk about rounding whole numbers here in this section. Now, let's talk about how we can round whole numbers and what the key and the trick behind this is in order to essentially round whole numbers. So we're going to look at several examples here. All right, so long division, use the calculator stuff. All right, so let's talk about rounding whole numbers. I wrote this down here earlier. So what's the key here? The key here is going to be circling and underlining. Now you're probably saying, okay, well, what's circling and what's underlying here? So the number we're going to circle here is the digit you want to possibly round up. I say the word possibly here. And the digit we're going to underline is the number to the right of what we circled. Okay, so we're going to circle a number and then underline the number to the right of that number that we circled. So let's go over a problem here, and we'll take a look at the steps here behind this. Now, if you've done rounding before, it's not too bad, but even in that case, you know, sometimes it can be confusing, especially when it asks you for very specific places it wants you to round to. So we want to be extra careful about that. Okay? So let's take that first one you see down there in letter A. So we got 83. We're going to round 83 to the nearest 10. Okay? So what we're going to do here is, first and foremost, if we're going to circle and underline, we're first going to identify what number is in the tens digit. So there's only two numbers here, there's 8 and 3. So go ahead and type it out in the chat here. What number is in the tens digit? Okay. All right, good. The answer indeed is 8. So since 8 is in the tens digit, and that's what we want to round to, the nearest 10, we're going to go ahead and circle that number. Okay? So this is the number here that we want to determine whether or not we're going to round up or not. And then we're going to underline the number to the right of that circled number there. In this case, obviously 3, since that's the only other number there. But again, this is how we would deal with any other number. Okay, so how do we determine whether we round up or we stay the same? Let's take a look here. So let's read this carefully here. There's a few key steps here. So first, what's the trick behind this? It says if the underlined, okay, again, if the underlined number is between 5 and 9, so including 5 and 9, then the circled number will go up 1. So it'll go up by 1 if that underlined number is between 5 and 9. If the underlined number is between 0 and 4, so 0, 1, 2, 3, 4, then the circled number stays the same. Okay, so what it comes down to is, in kind of what I had in my first class there, people kind of got confused about the, again, you just need to read this carefully here. You need to look at the underlying number. Okay, that's going to be our test number to determine whether the circled number is going to go up 1 or stay the same. Okay, so what happens in this case? Do we go up by 1 or do we stay the same? Stay the same, stay the same, stay the same. Okay, very good. The answer is correct. It is going to stay the same, absolutely. So we're going to bring this down here. We're going to keep the 8 exactly the same. All right, nothing will change. And that's because this underlined 3 is between 0 and 4. Now, there's one more thing that happens, of course, and that is deals with their underlying number and any other subsequent numbers. So here's something that's very important to note. Remember to change the underlying number and all numbers to the right of the underlying number to zeros. So once we're done rounding, any number that's underlined and any number to the right of that underlined number will now change over to zeros. So now this becomes 80 as a result. Okay, I'm going to do some more examples, of course. So let's go right into the next one. So we'll do that next one right there. 54,702. And here we're going to round to the nearest thousand. Okay, so let's take a good look here. So we want to find the nearest thousand. What number is the nearest thousand? What number is the thousandths place, I guess I should say. Guess we got 4, we got 7, and okay. I agree one of those is correct. The 5. Alright. Alright, so let's take a look here. See which one is right, because we got 3 answers kind of floating around, so one of them is correct. So the 2 is the 1 spot. This is the 10 spot. This is the 100 spot. Maybe I don't want to undo that. Alright. And then this last one here, this one here is the 1,000 spot right here. So the 1,000 spot goes right here. And then this is the 10,000 spot. This is the 10K spot. So if we want to look at the nearest 1,000, we're going to go ahead and circle the 4 here. So 4 was the correct answer for this. What's in the 1,000 spot? Well, that 4 is right there in that 1,000 spot. So I'm glad I asked this question here, just because, again, want to be sure you guys know that, which number to circle here in this case. So, again, it's not too bad. It's actually pretty simple once you see kind of the picture there. So, all right, what should I do next? What should I do next? Okay, underline the 7. I agree with that, right? Absolutely spot on, right? So we circled the 4. We've got to underline the 7. That's the number to the right of that 4. Okay, so here's our question here. Are we going to go round up 1, or are we going to stay the same? So I see a couple roundups, one stay the same. See two for 2. I see 1 and 3. See 1 to 4 rounding up. Okay, so let's go ahead and see which one it's going to be. Now remember, the answer to this is that it's going to round up by 1. Let's go ahead and take a look at why. the number that we underlined here was 7. So because the underlined number here is 7, that underlined number is between 5 and 9. Okay, so then the circle number here will go up by 1. So remember, the testing number here is not what you circled. The testing number here is what you underlined, the 7. Okay, that's why we use a circle and an underline technique here, is why I feel that this is easier, because then you can physically see, on paper you can see what number that you are going to test with and what number is going to be rounded up, because they are two separate things. So the testing number here is 7, and so we're going to go up by 1. So this 4 here now becomes a 5. So we have a 5 here, and then all the numbers starting from the underlined number to the right, those will all be 0. So our final answer here is going to be 55,000. Any questions about that? Hopefully that's not too bad. So I hope that made that clear there, because I want to be sure that you see where that's coming from there. Okay, let's go ahead and do another example then. All right. Okay. Yeah, that's the same thing. All right. So I'm gonna do that there. Okay. So the next number I'm gonna do here . Okay, so let's look at 9963, and we're going to look at the nearest 100. Okay, so we'll look at 9963, we're going to round to the nearest 100. So let's see what happens here in this case. All right, now we need to find the hundreds digit. So what number is that? What number is the hundreds digit here? All right, 9. Well, which 9? I agree it's 9, but which 9? The first 9 or the second 9? Okay, good. The second 9. Very good. So we're going to circle the second 9 here. All right, what's next? Underline 6. Okay, perfect. Totally agree with that. Very nice. Good, good. Okay, now let's look at what's next here. Okay, we have to determine whether or not we are going to round up by 1 or we're going to stay the same. So which one is it? Are we rounding up 1 or are we staying the same? Okay, we'll go round up. Okay. Okay. So I agree with all 3 of those answers that we are definitely going to round up by 1. But we got a problem. All right, the problem is that if we round up by 1, suddenly if I add 1 to here, this becomes 10, right? This becomes 10. 9 plus 1 is 10. Excuse me. So essentially, this is kind of an exception here to the rule. And I do want to point this out here, and I've stated this as such. So I'm going to bring up here the exception. What's the exception here? All right, for rounding. Well, it occurs what happens when you do have a 9 here. So let's read this off together. It says if a 9 rounds up, which in this case it does, we're going to change that to a 0. All right, so we're going to change this to a 0. And this 6 and 3 will also become 0. And we're going to add 1 to the next column over, the next column over being to the left, and keep repeating if necessary for adding 1 to the next column. So if there's a bunch of 9s here, for example, if you have like a bunch of 9s here to the left, you may keep adding 1 to the next column over until you finally stop. So that can happen. But here what we're going to do is we're going to add 1 to the next column over. 1 plus 9 is 10. And so even to the nearest 100 is still 10,000, okay, as a result. So if I said nearest 1,000, it would still be 10,000. The nearest 100 is also 10,000 for the same exact reason. Okay, so I wanted to point out this kind of exception here to the rule, so that way it's easier to kind of get where I came up with that. If you want to keep track of the homework here today, it'll be the end of section 1.5, 1.6, and the first half of 1.7. So get a lot done today. So as most of these concepts here are pretty quick. So go. All right, so that's pretty much how that works. Is if you circle and underline, it makes it like so significantly easier. Like you don't even have to guess. It's really, really easy once you can kind of physically see it with your own 2 eyes. Most of this is just what we've already done. Oh yeah, that we're doing later. Okay. Sure. Let me go ahead and put down another number here for the 9s, okay? I'll put down another number there. So let's try trying to think. Oh, okay. So if I had, in this case, the nearest 1,000, okay, so 29,532, okay. If I had the nearest 1,000, in this case here, again, the number I would circle is the 9, because that's the one that I need to see if I round up or I keep the same. And the number to the right here is 5. So 5, between 5 and 9, including 5, 9, means that I'm going to round this 9 up by 1. So if we talk about the rule here, let me bring that up again. The 9, if the 9 rounds up, you're going to change that 9 to a 0. Again, we're also going to keep the rule here of all the numbers from the underlined number all the way to the right. Those also will change to 0 as a result. But the other half of the exception here is we have to add 1 to the next column over to the left because we changed that 9 to a 0. In effect, think of it this way, Carissa. It's like if I had, if I added 2 numbers together and let's say they were 10 or more, 10 to 19, I would add 1 to the next column over, just kind of carrying it over. That's essentially what I'm doing here in this case as well. So I'm just going to add 1 to the next column over, then I have 2 plus 1, and I get 30,000 here as a result. So that was to kind of showcase like what happens in that particular instance. And that, again, that can repeat as many times as possible, but in this case we only added once, we got a 3, and we're good to go. Okay, no problem. That's what I'm here to do, hopefully make it make some sense. That's all that matters. Are there any other questions? No? All right. So if there are no more questions here, this is where I stopped in my first class, so this is where I'm going to stop here. We're going to do basically for next time here, just to let you know, we're going to do the latter half of this particular section, which is using rounding to add, subtract, multiply, do all that stuff. All right, so, or round an answer, rounding answers essentially, which isn't too hard. It's actually, again, fairly straightforward. And then we're going to get into section 1.8, which is exponents, roots, and order of operations. And if we have time, we are going to go to the last section here of chapter 1, which is section 1.10. So one thing that we're not doing here for this class, we're not doing section 1.9. 1.9 is going to be skipped. All right, so once we're going to go the latter half of 1.7, we'll do 1.8, and then we'll skip 1.9, and we'll do 1.10, which is the last section there of chapter 1. Once we're done with 1.10, I will be announcing the test pretty much at that time. So it just depends whether we get it done. I don't expect to get it done next class, but I have a pretty good expectation it'll get done by the next week. So next Tuesday probably is when I'll announce the first exam there. So that's basically kind of what's on the docket there for the next at least upcoming week. All right, so I'll let you know about more information about the test once I make that announcement. I know what I want to do. I just want to be sure that the rules are clear for you once I make that announcement for the test, so you'll know what you'll need to do. All right. Are there any other questions about that or anything else here from today? No? Okay. Great. All right. So I want to thank you all again for coming out here once again for today. Right after this is going to be office hours. So again, I'll be on, if you need to email me for office hours or if you want to stick around after class and ask a few questions, please feel free to do so. If not, and you're going to head out, I will see you on Thursday, okay? And I wish for those of you who are going to leave, I wish for those of you to have a very nice, happy, healthy day. All right? All right, see you on Thursday, Sion. You have a great one, okay? You have a wonderful afternoon, Hisa. All right. Okay. All right, everybody. I will be back in about maybe about 10 minutes or so, and if you want to be for, thank you. You have a wonderful rest of your day as well. Uh, I'll be back in about 10 minutes or so. For office hours. So, yeah, I'll be back then. All right. Take care, everybody, and we will see you later. Have a great one. All right. Bye.